It would not take too much effort to notice that there would be an incompatibility between the statement that space-time would be continuously inflating, as when a birthday balloon is blown up, and the thesis that this expansion would be taking place in the presence of constant acceleration. It is as if you were saying that the negative phase of spring stretching in a spring mass set is accompanied by acceleration. This model describes the simple harmonic movement performed by light, but which we usually extend to the behavior of space. In our visible universe, light would act as a messenger of space, which would be excluded in the process. In the aforementioned set, the force exerted by the spring on the block may have a negative or positive orientation, as it is a system of conservative forces. That is, whether in the expansionary phase of the spring, or in its contraction, the force always points to the rest position. In this case, the spring of the set would always exert the influence of its force in the opposite direction to its stretching or contraction. Thus, when space was described by light, its inflation would be compatible with the spring stretching phase of the set, the first. In this phase, the work exerted by the spring would be negative and retrograde, being accompanied by deceleration of the movement of the block. In the case of space, and according to the theory of relativity, its expansion should contract time in a complementary way. Acceleration would arise only when space was already secondarily contracting. This would happen already in a phase when the spring work is positive and restorative. Who tells us that the universe is in continuous expansion is the microwave background radiation, which would reach us with an immense delay. This radiation would reveal a predominance of the bands of the spectrum that tend towards the red. Light, like all other forms of radiation, is the only supposedly reliable source of information that allows us to make considerations about what is totally beyond our direct reach in space. This is the case with the light of the stars and the galaxies that they form. The light waves they emit need, at first, to accommodate themselves to the curvature of space, and only then, secondarily provide access to the information they carry. It is assumed that this accommodation movement would take time in our future, and, due to the delay in communicating the event through light, it would forcibly break the direct link between the alteration of the geometry of space and what light would communicate to us in the present. That is, this geometric alteration would have remained in our past. If space were to stretch or expand in our future, it could be generating inertia in a veiled way, because the future has not yet happened. Inertia takes precedence over gravity, at the same time that it predisposes to the secondary accommodation of electromagnetic waves to the curvature of space. This veiled action of space would not depend on the direct influence of the masses of the celestial bodies. In the case of distant galaxies, the only interaction that really makes sense is the one that takes place at the observer's position, when the reports carried by the light are made available with an inevitable delay. At this moment, the ground zero of time already appears at the observer's position, who would not be aware of the existence of any time module that perhaps had existed previously or in the future. The time that we compute from the Big Bang to the present day only makes sense through a process of extrapolation of concepts, which we elaborate from the present. that 13.7 billion years are always measured indirectly, using a huge range of highly sensitive equipment, based on the remote tracking of information contained in light. We don't have equipment that allows us to track the space itself. A fictitious path is traversed through the light, captured by our antennas, which would point towards the past, a place that is not part of the physical reality of the universe. When light manifests at our position, the actual change in the geometry of space is likely not to be there anymore, at least as it can be described by electromagnetic waves. As the zero reference of time is always in the position of the observer, there is also no way to directly characterize the expected movement of light in our future. Without measurable time directly in our future, there is also no measurable motion or acceleration. The universe would become stationary in the direction of the arrow of time. The expansionary movement would have been established from the Big Bang. It would be communicated to us by the delayed cosmic background radiation. If this movement really existed, it would have to be retrograde, with a predominance of elastic potential energy over kinetic energy. That's because when space stretches, its messenger, the only form of communication available, would have to be in the first phase of its simple harmonic motion. All the time required for the spring of space to stretch, and which would have been separating us from the Big Bang, would have virtually ceased to exist when the 0 point of time suddenly appeared at our present position. It would be as if the expansion of space had imploded time until the moment when the light, emitted in the singularity, manifested itself next to us. It is said that the stretching of space would contract time until the contraction reached levels of time that we could no longer measure. As the contraction of time could not be total without hurting the uncertainty principle, this time would only reach subliminal levels, or whose modules could not be measured directly. Time, which might exist in our future, would have come to compose the collection of our memory. It would be thanks to the retention of time in our future that we could instantly look back at the entire past of the universe, reaching very close to the Big Bang. It is concluded that the uncertainty of the position or speed of light sources would be supporting the functioning of our memory. The reversal in the direction of the arrow of time in our present, which would have come to point in the direction of our past, would be apparent. It would result from the virtual existence of time in the future. The light waves tell us that the expansion and stretching of the spring of space would be ongoing at present, but the communication is undoubtedly delayed. There could be no moving waves in the future, or in a place in the universe where time could not be measured directly. To communicate inflation, light would need to accommodate, secondarily, to changes in the geometry of space. Centripetal relaxation would correspond to the second phase of the spring mass set, that of contraction. It would be the positive restoration of the force that, in the final analyses, would allow the availability of the reports carried by the cosmic radiation, now called the background. At the moment when this happens, the inflation, prevailing in the first phase, would manifest itself in the presence of gravity and acceleration. These would be characteristics of the second phase of harmonic motion. Even so, the two phases apparently overlap due to the lagged availability of the reports. The effects of the independent expansion and contraction phases mix in spacetime, and it becomes homogeneous and isotropic. That is, light no longer depends on the direction of its propagation. Thus, remote tracking does not allow us to say, with certainty, whether the arrow of time points to the future or to the past. The Big Bang is usually defined as the end result of a singularity. Some physicists defend the thesis that it would have resulted from the gravitational collapse of a very high-mass body, forming a black hole. According to Stephen Hawking, if you tried to approach a black hole, your time would run out. Thus, we can ask whether the Big Bang should not be taking place relatively in our future when it comes to the input of the reports that could escape it. This play on words emphasizes the importance of the finding that time would be virtually contained in the very observer. In this case, the Big Bang singularity would have to be happening here and now, developing, perhaps, only in a field of information made available by cosmic radiation. If the observer could only look at the present of the universe with a delay, the idea that there would be a time running in the future could only result from a transient retention of the reports. Furthermore, the resulting retention of time in the future could be happening intrinsically within the observer himself and not outside him, as is normally supposed. In this case, time would not be part of physical reality, being a kind of illusion that would be putting the observer in a form of temporal exile within the universe itself. Outside of the time he can measure, the universe would be stationary.